Okay, so it's after lunch, I know. It's going to be hard, but I will try to keep you engaged. And to do that, I'll start with a personal story. Back in 2021, I was working at Logs.io. And yeah. So I was given a task, quite a big one, to refactor a system that we had. It's an infrastructure system because multiple microservices used it. It was actually a work queue. And I would give you one tip: don't try to write your own work queue. It's never a good idea. So eventually we reached the bottleneck, and I needed to start searching to see what other people are doing. So I knew I needed a distributed work queue. I mean, it's executing a lot of alerts. It's running aggregation jobs. So I knew I need something that would handle the high throughput. And you start Googling, right? Today ChatGPT. And then I bounced into Apache Pulsar. And as I started reading about it more and more, I realized that this is actually a gem. This is something that not a lot of people know about, and it's simply brilliant. I really love that product. So you wouldn't be surprised that 1 year later, I found myself working as a principal engineer in Stream Native. And Stream Native, and 1 year afterwards, just 1 month ago, I was invited to be an Apache Pulsar committer. And as you can imagine, Stream Native actually offers Apache Pulsar as a service, and you have those free flavors that you can pick. And lately, we actually have Kafka-compatible protocol on Stream Native. So my goal in this lecture, in this 45, 50 minutes lecture, when we end it, I want you to understand what is Pulsar, understand its architecture, and be able to explain to your friends what is it and the feature it has. And I think the best way to begin is taking a walk around the neighborhood of Pulsar. And the neighborhood of Pulsar has two prominent neighbors, Kafka and RabbitMQ. And I think we're going to start with Kafka. So, Kafka, for those, I guess, how many people use Kafka and know it? Okay, quite a lot. But some people think they know it, but they don't. So we'll do like a quick overview of what it is. And then it will help us understand Pulsar better. Okay, so we're starting with the Kafka client. The Kafka client contains a producer. So the producer is the one that's actually sending messages to a topic. So as you can imagine, you write in a certain order to the topic, and then you want to consume for it. And when you consume from the messages, when you read the messages, you read them in the same order that you wrote them. Up to now, pretty easy. Now, as you can imagine, you put a topic on a single machine, and it's too much, right? And you need to parallelize it to make it faster, so you can write faster, you can consume faster. So Kafka gives you the ability to actually divide the topic. Okay, it's called partitions. So in order to do that, in order to enjoy more than one machine, Kafka was designed to be a distributed system. So the server side, called the broker, has basically more than one. You have a set of brokers, and those topics that we were talking about before, when you write to a topic, you're actually writing into a partition. And the partition is the real topic. It's like the mini topic. This is where the order is kept. So you write actually to a partition in a certain order, and then you read in that certain order by the consumers. Now, in your microservice, you would have, in your instance of your microservice, you would have one consumer, okay? And that consumer would read, let's say, if you have only one, read all the partitions, okay? But you need more than one. So you spin up more machines, you have more consumers, and they simply split the partitions between them. I will take this partition, I will take this partition. So this thing actually, how did they know that they work together? How do they know only those microservice will split the partition between them. When you actually launch a consumer, when you define it in the context of something called a consumer group. Okay, you give it a name, and they all know how we're together in the same consumer group. We're going to split the partitions between us. What happens when you restart your service? Are you beginning from the beginning? No. You don't want to lose what you processed up until now. So Kafka gives you this simple thing called an offset. So basically an offset says, I read and processed and finished processing all the messages up to that point. Okay, and we have that offset, as you can imagine, per partition. Okay, and basically those offsets are saved in the context of a consumer group. We can have more than one group, okay, and that group would have completely different offsets. Okay, that's Kafka in a nutshell, reading in a certain order based on the order in the partitions. Now, we also have the other neighbor. We have RabbitMQ. And I think the first thing people ask, like, why do I need RabbitMQ? I have Kafka, right? I can publish messages, read. Let's take a closer look to understand. I have this topic, okay? It's actually a partition, okay? And this is the offset. I read up to that message, everything up to that message, and now I'm taking 4 more messages. And I succeeded in 2 of them, but those failed. So, and now you're in a crossroad. You have to ask yourself, what I'm going to do? I can decide to move the offset up to the final message, but what will happen if I will restart my microservice? I will never get those failed messages back. Okay? So I can retry, okay? But if now I move the offset and I retry, and I will never get us back because the offset will be there. I don't want to lose the messages, right? So I said, no, I will not move the offset. I will keep it there. I will continue pulling more messages, reading more messages from the partition, okay? And I will continue to retry. But what would happen now? When I will be restarted, I would lose way more messages because I'm still here. I haven't finished. So obviously, it's not good. So people need some workarounds. So how do they work around it? They do this. They read the messages to the application, but they create a new topic. Okay? It's a topic that is actually named failed processing. Okay? It's based on the consumer group name because it's specific to the consumer group. And so I read the messages, and those that failed, I simply write them here. And then I can move the offset. All is good, right? Not really. Of course, you have to now add another extra read because you have to read, but it's not a big problem. The big problem is that the same problem will happen here, right? Because some will work, some wouldn't. So should I move the offset? No, it's the same problem. I actually haven't solved it. So basically, what we really want is an individual acknowledgement. I want to be able to say, I finished with 4 and I finished with 6, but not with the other 5 and 7. That's what I really want. And that's the reason people use RabbitMQ. Because RabbitMQ gives you exactly that, individual acknowledgement. And then you're asking, wait a minute, what's missing in RabbitMQ? I think the biggest piece, it's not horizontally scalable. Okay, it wasn't designed, it was designed back then. You cannot spin 100 machines. It wasn't designed from the get-go to be such. And so it wasn't designed for reading in order. Same as in Kafka. Simply wasn't designed for this high throughput. So basically you're saying, okay, so I actually need always 2 systems, right? One to do streaming in order, really high throughput, and the other one for doing a walk queue, right? I want to send a notification, run a report, right? And I need to know if it failed, I will retry again. So I always need 2. But I don't want 2 systems. What happens if you need 2 systems? You have to learn it, you have to deploy it, you have to secure it. It's a headache, right? So what you really want, okay, the ideal situation is to have one system that is horizontally scalable, can process in order, you can process out of order, individual acknowledgement, and everything, of course, with super low latency. That's exactly what Pulsar is. Okay, so Pulsar is a messaging and a streaming system. It's like Kafka and RabbitMQ together on a single machine with the high scalability and high throughput. That's the basics. But now that you know the basics, but actually, it's what I told you, it's only, I would say, a single feature out of it. It's actually, there is much more. It's actually the beginning of the tip of the iceberg. And now what I want you to know, I want you to cover all the features it has, more than that. But in order to do that, first we have to understand Pulsar basics. Okay, so a producer, this is the basics. A producer, write a message to topic. Topic can be partitioned. And when you consume, okay, you consume in the context of something called a subscription. It's like a consumer group, but it has a type. And there are 4 types that you can choose. And the type basically dictates how the broker will distribute the message to the consumers. First type, called shared. So in shared, all the consumers are connecting to all the partitions. And then what happens, it keeps clicking. And then what happens, what the broker does is now a round robin of the messages to the different consumers. And in that mode, what you do, you actually do individual acknowledgement. You acknowledge the message that you're finished working with. Okay, that's the shared subscription. The other one, the other type, is called a failover. So in failover, again, all the consumers are connected to all the partitions, but only one is allowed to be active. Okay, so that means only one is reading the messages. Only one consumer is reading that partition. So you're basically reading in the same order it was written to, right? And all the other one are in standby. So if something happened, they fail over to the other one. That's the name. And when you have that one, okay, so in that mode, in that failover mode, what you actually do, you do cumulative acknowledge. Okay, because I finished up to that message. That's the subscription called the type failover. You have two other types. You have key shared and exclusive. I don't have the time to cover them, but they're very good, really good, especially the key shared. It's a unique type that Pulsar has. So if we summarize, so a subscription basically holds the state of the consumption of the message. Okay? Okay, now we understand the Pulsar basics. Now let's understand the architecture of Pulsar. And sometimes it's best when you compare it to something you already know. And I think you already raised your hands. Everybody knows Kafka here, most of you. So you do know that when the producer writes a message to a partition, it needs to find which broker is actually responsible for that partition, because the partition only lives in one of the brokers. Okay? So you find the one that is responsible, and you write the messages to it. And then, when you write the message to it, each partition has a local file, a file on the hard drive of that broker, a file matching that partition. So it simply appends the data to that file, to that local file. Okay, it's an append-only local file. That's Kafka. How does it look in Pulsar? So at Pulsar, it's very similar. So the producer writes the message to the broker. It's the same thing. They each own each partition, distributed. But when the message is written, okay, each partition it's not writing it to a local file. It's writing it to a virtual file. It's a virtual append-only file. And that file actually lives in another system. That system is called Apache Bookkeeper. Okay? And that system, as you can imagine, is essentially a distributed append-only file system. Okay? That's the purpose of Bookkeeper. And that virtual append-only file is called a ledger. Okay? So you write into a ledger. So how does it look like? You write to a ledger. The application happens within Bookkeeper. So basically, the broker writes in parallel to 3 bookies, each hosting that ledger. In Kafka, I don't know if you know it, when you write the messages to that local file, after a certain time or size, it actually rotates the file, moves it to the side. That file will not be touched again, immutable. A new file is opened, and you write to that file, and repeats itself. The same in Pulsar. So when we're finished with that ledger, with that virtual file, we're basically opening a new one. What happens when you open a new one? Pulsar, basically Bookkeeper client, Pulsar, broker, selects an arbitrary 3 bookies and, to host that new ledger, and it writes to them. And then it repeats itself. Now it will go on those bookies. So as you can see here, that topic, that partition data actually lives in all the bookies, essentially. Maybe not all, but it's spread across the bookies. It's not co-located in a single node. Not a broker and not a bookie. So if we zoom out a little bit, just to summarize, we have Pulsar. Okay, so Pulsar is a set of brokers, okay? And the Pulsar writes the data into a system called Bookkeeper, which is a set of bookies. And Pulsar and Bookkeeper both write the metadata into Zookeeper. Zookeeper, for example, Pulsar, the classic metadata would say, for a given topic, what is the list of ledger IDs of that topic, right? Because I keep opening ledgers. And for Bookkeeper, it would be, for a given ledger ID, where are the bookies? Which are the bookies that host that ledger? That's Pulsar architecture. Now that we understand that, I think now we can cover the features, and I will show you now what features it unlocks. I would start with the killer feature, my favorite one, rapid scalability. Let's take a classic use case. I think people probably have it. This is Kafka. Okay, you have brokers, you have partitions spread across. It's Thursday night, right? I'd say 6 o'clock. You're ready to close the laptop. You want to go home. And then PagerDuty starts beeping. Everybody with a different noise. And then you look and you see, oh my God, the incoming traffic suddenly spiked 3 times. The cluster is almost at 100% capacity. You say, oh, what do we do? It's Thursday night, I want to go home. So I say, oh, wait a minute. Kafka is a distributed system, right? That's the whole idea. So no problem, I just add more brokers. Great, I add more brokers. And then nothing happens. Yeah, you heard it. Nothing happens. That's the way Kafka is designed. So what is written in the manual? You should actually run this shell script, okay? This will actually give you a plan, like a JSON file that says, in an ideal situation, this is where each partition should be. Now you have to execute that plan. So you execute that plan, and then basically you can go grab a beer, watch a movie, have a long one. You can even eat a restaurant and continue. Why? Because it takes hours, okay? Why? Because when you move a partition from this broker to the other one, you have to copy the data locally from that hard drive to that hard drive over the network. And that data can be hundreds of gigabytes, sometimes terabytes. That takes hours. And what do you think happens in those hours? Your system is crashing, okay? Okay, after a few hours, the data is balanced, okay, your system was basically out for a few hours. Bad, right? Quite bad. So it's impossible, right? You don't want to, nobody lives with that. So we have workaround. And you know what is the default workaround that everybody is using? Money. Money. You simply provision to the max. So, okay, 3 times more broker. Most of the time, they sit idle. You're paying for nothing. But that's what you have to do. That's the architecture. What can you do? Some write their own logic. Okay, I'll stop. I'll create new topics and I will switch them. And actually, I tried it. It's complicated, and then you leave the company and people hate you. Okay, I tried it as well. It's better. Let me show you how this whole scenario looks in Pulsar. Okay, so let's start with an even easier scenario, okay? You now spin up a new application, okay, new microservice that now wants to read an existing data, an existing topic, start reading it, so the consumption goes up, okay, just the consumption. So you need more CPU, right? You need more memory, you need more network, so you just add more brokers in Pulsar. When you do that, Pulsar has an automatic load balancer. It kicks in automatically. It goes and looks at the load of each partition, looks at the memory of the broker, the CPU, everything, takes everything into account and start moving the partitions all around. And remember that there's no data, right? So it's moving it almost instantaneously. We're talking seconds, okay? Tens of seconds, and that's it. Your cluster is fully balanced. Woohoo! That's great. Let's go back to the other scenario, right? A Thursday night. Suddenly, your traffic spikes 3 times. So you need more I/O, right? So, okay, so you add more bookies. Now what happens? If you remember, we said that each partition, every size or time, keeps rotating the ledgers. What happens is that when you start, it's almost immediately selected on, because you select always arbitrary free bookies, and you do it for all the partitions in the cluster. So quickly, they're used to be part of a ledger. And then more ledger and more ledger, I'm talking about tens of seconds, minutes, those bookies are fully used and are basically using all the bookie power that you just started, right? All the I/O. So in that case, okay, if we summarize, if you have Pulsar, that architecture unlocks the ability to have rapid scalability. Okay, in minutes, the problem is solved. Now that's incredible. Let's talk about another feature. Now this is Israel, and I guess maybe 50% here are working in startups, maybe 10 people, 15 people, you all know each other, right? You know what everybody is doing. One Kafka cluster is enough for everybody. What happens if your organization is bigger? Okay, we're talking 300 people, 500 employees. Now you don't want like one team accidentally deletes your topic, one team accidentally writes to your topic, right? You want permissions. And the second thing you say, I don't want suddenly there is a spike in one application, it's killing the broker, but I'm also on that broker, so they're killing me. So you want like quotas. So what people normally do in Kafka? They spin up Kafka cluster for each team because it's easy, okay? But it's not. It's easy for you, the developer, but for the DevOps, it's exponentially harder because you need to manage a fleet of Kafka clusters, okay? And you have to start developing. And why do you have to start developing it? Why? Why it's so hard to have multi-tenancy in Kafka? Let's have a look, okay? Permissions. What do Kafka give you to do permissions? So they don't have tenants or teams or something like that. So you have to invent it. Where? In the topic name. So you can do something like that. You can have the topic name, you want to force it to have tenant.project.topic. Okay? And how do you force it? You have this topic name policy that you can employ, but many eventually build their own system that people request topics into a single system. And they shut down the topic auto-creation to control it. It's complicated, but it's possible. Let's assume you actually did it. Now, you can give what's called an ACL, like I can give permissions to a user to a given topic, but not just one topic, I can give it to a prefix, okay, based on up to this to a tenant, up to this to a project. If you try to imagine, by the way, doing that, managing permissions like that, it's complicated, okay, it's cumbersome. And the worst part, the ability to give a user a permission, only the cluster 11 admin can do it. No self-service. You have to go to that person and keep hammering them about it. And if you need different authentication for each admin, JWT, OAuth, you can't. Because it's one authentication for the entire cluster. So I think now we start to understand why people have a fleet of clusters, and eventually they say, it's too much to manage that, I'm going to a vendor. Okay, Confluent would be your primary choice, I would guess. How does it look like in Pulsar? So Pulsar, let me tell you a little story. Pulsar was actually designed in Yahoo in 2011. Okay, they actually wanted to have a single messaging platform for all their needs. So in the design phase, in 2011, they actually took multi-tenancy into the design. So Pulsar has those notions. So it has something called a tenant, and a tenant has a set of namespaces, and each namespace has a set of topics. So now, you can have something like that. You can give a user a tenant admin role. You can take somebody from your team, say you are the tenant admin. And then that user can assign permissions. Okay, but it's easy cognitive load. You say, I want to give that user those set of topics. Maybe those set of namespaces. Maybe the entire tenant. It's easier to manage it like that. So when you have that, what happens is suddenly Pulsar can become like a single platform. Okay, you can use it as a single platform to basically, and every department can manage themselves. The thing is, also, each tenant can have their own authentication. Okay, JWT, OAuth2, it's not cluster level, it's tenant level. It makes sense. Okay, the other one, we talked about quotas, right? Something called a noisy neighbor, sometimes people call it. So Kafka, what Kafka gives you, Kafka gives the ability to have a quota, like I want no more than 5 megabytes per second, okay, so in Kafka, it's for a given user. So a user basically would probably be your application. Okay, so you can limit for a given broker, you take a broker and you say 5 megabytes a second for that application. Okay, but you remember that the user has access to multiple topics, okay? So, again, sometimes it's hard to manage it if you're looking at it from the perspective of an application. So in Pulsar, they took a different approach. Basically, they're saying, you have that, but it's on a, you can give it the rate limit on a topic level, okay, 5 megabytes a second per topic, or 5 megabytes a second per namespace. Okay? And of course, it's per broker. Sometimes it's easier to manage it like that on a topic or namespace level. And there is work, half of it is already there in the code, but it's not yet done, to do it on a tenant level, which is ideal. But it's not there yet. And if you need it, you can actually say, I'm going to take a set of brokers and a set of bookies and isolate them only to a specific tenant. If you need it. Like that's the perfect isolation if you really need it. Let's talk about another feature. That was multi-tenancy. Let's talk about Geo-replication. Some of you don't need it at all. some of you actually do need it. For those who need it, let me explain to you how it looks like in both. Okay, so imagine your users are walking in front of one geographic region, let's say EU, okay? And so it has all the brokers, it has all your microservices, the consumer and producers, right? But imagine that it actually dies, okay? This region goes down. So what, in an ideal situation, okay, if you have money to pay for it, yeah? You would have your entire application duplicated, right? All the brokers, all the application, everything in another region, another geographic region in US. Then you simply switch your users to US, okay? And in an ideal situation, all the data is already there, okay, in Kafka. And the consumer offsets, right, where you stopped reading, would also be there, okay? And then you just continue from where you left off. And then suddenly when it goes back to being live, it can resume being a standby, syncs everything, and then you can switch it back if you want to be active. And this goes back to standby. Active standby. That's what you want. So how does it look in Kafka? Let's start by saying that Kafka doesn't have it built in. Okay, so what do you have to do to have it? You have to install a Kafka Connect cluster, and you have to install it in both regions. And then you install an application, a Kafka Connect application called Mirror Maker 2. What Mirror Maker 2 does, essentially, is simply reads the data from the topic you want to replicate and writes it into the other cluster. But it has one unique, weird thing. It's a design choice. It's not written to orders as you would expect. It's actually written to EU orders. And when the other goes, and the other way around, it would read from here and write it into US orders. So if you look here for a second, that means that you, the application, okay, you have to change it. Because you have to do the merge yourself. You have to say, okay, first I'm going to check if suddenly I have EU orders. I'm going to read from that first, and when it's finished, I'm going to write it here, okay? If you think about it in your head, running the scenarios, it's complicated, and you have to change your code to support Geo-replication. Not so fun, right? And of course, it also copies the consumer groups, okay? But all the consumer groups are actually on that topic. Again, complicated. In Pulsar was written, again, it's baked in, the Geo-replication. So the data is copied from orders to orders, and it's two-way replication. So it can actually be, even if you want active-active, you can write to both, because it's designed to be this way. So basically, the Geo-replication is built in. You don't need to re-architect your application. The subscription state itself is also replicated. And as I told you, right now it actually supports many types of topologies, even active-active. And last is that the client itself, you can give it a URL. And it will dynamically, the response of the URL will tell it which cluster is the active one. And then it will simply switch dynamically based on this response. So you can have it, it's baked into the client. Okay? So if you do need Geo-replication, it's expensive to have it, it's easier. Let's talk about a nice, interesting use case that I just saw a while ago. There's this company called Cogito, okay? And they have this software, okay, that they sell to customers. They basically run like an operator, okay? So imagine customer service having a lot of phone calls. So it's all routed through their software. Okay, so the phone call is routed through the software and ends up in the other line, right? Caller and the operator, and the customer support service. So when you think about it, on a telephone call, you want one thing, is the conversation to reach the other side. But what if you want to transcribe it in real time? What if you want to analyze it later? Okay, so a lot of time what you actually need something that's actually like Kafka. So you want to put it in Kafka, then do all the stuff. Route it in real time to the other side of the caller, analyze it, everything, right? Multiple consumer groups, remember? So what you would want to have, because you have 600,000 phone calls, you would want to, the easiest thing to develop is to say, okay, I want to have a topic per phone conversation, okay? It's the easiest to write your code. Easiest for many things. But the thing is, you can't. So you have to do like this, many people doing, like a multi-tenancy on the topic. And it's hard. I think that just a while ago, I think Nadav from Gong, I don't know if you're here. Yeah, so he has a great lecture in Java.IL, if you look at it on YouTube, so how they do multi-tenancy in Gong for something similar. It's hard, okay, multi-tenancy on the same topic, writing easy. So in the Kafka, if you want to do something like that in Kafka, you have to remember that a partition of a topic is actually a real physical file. And if you look at it, how much can you write in parallel? How much files can you write in parallel in one broker? So it's natural to have no more than 4,000 partitions on a topic. Give or take, but it will not be 10x than that. Okay? So what people do to solve it? So they write to a topic, right? Everything, all the conversations, and then they use Kafka streams to start splitting it into that specific call ID or account ID, and then it would go to S3. It's very complicated. Then you have this S3 file that has only the account ID information you need. Yeah, you can do it, but it's very complicated. Now in Pulsar is, remember that a partition is writing to a virtual file. So there is no one-to-one mapping between a virtual file and an actual file, because it's a virtual file. But you say, oh, you're cheating, because if we look at the bookkeeper, then we will find this mapping, right? So each partition would have a virtual file, and that virtual file is an actual file. No. If you look at the data file, once in a while it flushes the data from memory to disk, take a look at the data file in bookkeeper, you would actually find many ledgers, data from many ledger IDs, many virtual files, okay? There's no one-to-one mapping. That means that finding a Pulsar cluster that has 600,000 topics is not something that would be hard to find. Cogito is an actual use case, okay? They actually create 2 million topics in a day because it's very transient. So Pulsar, if we summarize, can support up to 1 million topics. And the reason is the architecture I showed before. I think that's an incredible feature. So it opens possibilities that you couldn't even imagine. Let's talk about another problem that we have in Kafka. Okay? Retention, right? It's best to have unlimited retention. So fortunately, Kafka added it. So how does it look like, this thing called tiered storage, solving that issue? So we have the broker. It writes to the data, to the file of that partition. And once the file is immutable, you can, because the file is rotated, right? Never written again, copy to S3. And when you need it, or you can delete it, right? You don't need it there. And when you need it, you can just stream it directly from S3. There, you got unlimited retention, which is fantastic. But you have to remember that with Kafka, it's fairly new. Okay? If you read the docs, it still has quite a few limitations. And they say, please don't use it in production. But it will all be, in 1 year from now, I have to delete these bullets. Okay? Because everything will be okay. But it was designed not to be bundled with the code you need, because most of you probably want it to work with S3. No. You have to go and grab a plugin from, it's not an Apache Foundation, governance community. No, it's a different community. It's not even in a foundation. Maybe Avon has it, it's a company. So they developed a plugin, and you can go to Red Hat, okay, and they have their own governance. And lately, I don't know if you saw, open source that are not in foundation have this tendency to go away sometimes, okay, and vanish. And they have their own structure. So just so you know, it's a different community. So in Kafka, you get the bare bones interface. That's it. In Pulsar, it's the same thing, okay? So once the ledger is not written anymore, it's immutable, you just read the ledger and copy it to S3, and then when you need it, you're just reading it, streaming it from S3. But the most important thing, it has baked-in support for all the cloud vendors. And it has been this way for a few years. Let's talk about another feature. It's delayed messages. Now, what if you need to, let's say, schedule an email? I mean, who doesn't need it? I want to send an email to a customer, let's say in 1 hour, maybe in 1 day. You want to send a Slack notification. Maybe you want to run a scheduled report, okay, in the future, right? So delayed messages. How do you do it in Kafka? You don't. Doesn't exist. And then you have to go and do the other thing, like go to find other systems and don't invent it. You can go and use temporal. Okay, it's a nice system, has its flaws. You can go to serverless and many others. Okay, but you have to have another system. Wouldn't it be nice if you can just do this? Pulsar, new message, deliver after. That's it, send. That's Pulsar. It's built in. Now let's talk about the last feature I want to talk about in depth, okay? Because still it's a hard time to listen to those lectures. Guaranteed message persistency. Let's spend 2 minutes on this. When you write a message, okay? When you write a message to this partition, it goes to the local file, okay? And then it waits for the other two brokers to write it, to replicate it. So they read from this broker 1, write it to their local file, and then send sort of an acknowledgement back, and then only then you acknowledge back to the producer. So you know the file was written to 3 replicas, great, if something happens, burned to the fire, so you have it. And you also know it was written, so it's not just in memory, right? So it's safe. Actually, no. When you write it to that local file, each one of those, it actually writes it to memory. Yes, it writes it to memory. And then the operating system has its own decision when to flush it from memory to disk. So, imagine a scenario, far-fetched, I mean, not far-fetched completely, but it can happen, that you write it, you acknowledge back to the producer, which then on the UI you say, financial transaction completed successfully. You can close everything, okay? And then at this same millisecond, all 3 brokers lost power at the same time. Just lost power, okay? I guess some of you are working with Amazon EC2. I mean, it's like, how does it go? The disaster monkey, I forgot the name. But it's like, it can happen, okay? Chaos monkey. So it can happen. And when you lose power at the same time, it didn't have time to flash it to disk. So you don't have a guaranteed persistency. How does it look in Pulsar? So in Pulsar, you write into the broker, it writes into the ledgers in the bookies, 3 bookies in parallel, and the ledgers the bookies write it to a local file, okay, called a write-ahead log, okay, and then write it to memory, normal design. And what happens in the bookie groups a bunch of writes to the write-ahead log, and then decide for throughput reasons to batch it together, and only then flash it to disk, something called an fsync. Okay, so it groups the writes together to the write-ahead log, and flash it fsync. It's guaranteed to be on the disk, and then it goes and say, I'm done, to the broker. And then the other one, right? And then you can acknowledge back. So basically, what happens is that in this design, you have something called a guaranteed message persistency. You know for sure, okay, that it's both replicated, if something completely goes haywire, on fire, and even if you have only one, but it lost power, it's still there. If you plug the power back, it's going to be there for sure. Now, 99% of your data, or maybe 90%, you don't need it. Because you don't care that much. You do care, but you can live with it, okay, with the chance. Why? Because it does cost something in throughput, right? Because you have to wait. You have to group and then wait and write, so it latency. Okay, so it reduces latency, reduces throughput in a way. And but you want the ability to choose. For that data, I do want it. I'm willing to pay the price. It's not that high throughput data. So in that data, I do want it to guaranteed message persistency, and you can choose. And in Kafka, you can. Now, we don't have that much more time. How much time do we have? 2 minutes? Okay, so I don't have time, so I'll just cover quickly. You have, in Pulsar, we remember that the broker is stateless. It doesn't really need any hard drive. And the bookie is the one saving the data. So the broker is CPU intensive, and the bookie is IO intensive. In EC2, you can choose a machine that is designed for it. So you can spend your money wisely. You have something called, you can write 100 megabyte messages in Pulsar, because the client support client-side chunking. So you can write 100, even more. In Pulsar, you have 5 officially supported client languages. In Kafka, you have 1, Java. And there's a new metadata store that is recently open sourced. It's like Zookeeper, but written for Kubernetes. It's called Oxia. And it's actually, it's actually partitions data, but I won't go into it right now. It has a built-in schema registry, transaction support, and actually much more. And I'm going to spend the last, I would say, 1 minute, maybe 1.5 minutes about what's the catch, right? I mean, it's a given question, like, you're giving me all this good stuff, where's the bad stuff? Okay, well, here's the bad stuff. First, you have to understand and operate 2 systems. So it's a bookkeeper cluster and a Pulsar broker cluster. But do have to say that from talking to people that actually running it in production, bookkeeper seems to be quite a stable cluster. So it's not something that will knock you out of your zone. But you say, wait, we have Zookeeper, right? Zookeeper is also a system, right? So is it a free system and Kafka is only 1? Because Kafka removed Zookeeper, right? You remember? It's actually a lie. It's a really great marketing lie. When you read the documentation, their embedded Zookeeper called Kraft, you have to run it separately in 3 separate machines. So basically, you're running 2 systems, Kraft and Kafka, and it's a new system. So even if you Google it, you wouldn't find that much errors. The other bad stuff is that, as you can imagine, Pulsar is still an early stage adoption phase, and it has consequences. Okay, like It has big companies that are using it, okay? There are Tencent and Flipkart and Yahoo and ING, but the majority are not. It's still early stage. So you have to be the pioneer that does it. But I can tell you that, and another aspect of it is that if you read the documentation, it's very comprehensive. It has everything you need to know, but it's like an encyclopedia. So you have to spend time to understand it. The flip side, and I'm there, I'm on Slack, the Slack members are very helpful. Okay, so any question you have when reading that encyclopedia, people will help you. So if you want to be that pioneer, people will help you, including myself, because you have a member. And last part, and that's it. The ecosystem is not mature yet. Okay, so you use libraries and other tools and stuff. A lot of it has today Kafka support, but in Pulsar, you wouldn't find in every library. Sometimes it would, so you have to check. That's it. So I hope I think I would summarize that I think Pulsar, in my opinion, is called the next generation messaging and streaming system, and it has a reason it is called this way. So I hope I urge you to give it a go and try reading it. Thank you.